Hello everyone, my name is Mojtaba and I will present our journal first paper, Execution of Partial State Machine Models. First, let me discuss briefly why do we need to execute partial models. Software development using models is an iterative and incremental process. Therefore, the model of a system is partial until a certain stage of the software development. Execution of partial models allows the execution and debugging of models at the early stage of the software development. Studies shows that fixing defects earlier is easier and less expensive. Often, a software system is developed by a team of software developers. Each developer is responsible for developing certain components. During the development, they may need to test and debug the relevant components while the other dependent components are not yet complete or available. In this case, execution of partial models allows each developer to execute the components they have been developing without waiting for other developers. Finally, it's not reasonable and efficient to apply some of the analysis and testing techniques on the whole model. Therefore, they are applied on the components of interest, which can be treated as partial models. Our approach for the execution of partial models takes user-defined models as input. Then it uses static analysis that respect the execution semantics of models and extract the problematic elements that cause a lack of progress and reachability for the execution. Then it uses model transformation to fix the problematic elements. A fix for some element is simple and deterministic, so they can be fixed at design time. But for most of the problematic elements, several fixes can be applied. In these cases, we refine the model such that users can decide about them at runtime. Finally, users are allowed to execute the refined models. When the execution reaches problematic element at runtime, the user can provide input interactively or using a script to continue the execution. While our focus in this work is the execution of partial state machine models, but a similar approach can be applied for other modeling languages. Let me discuss how the proposed approach is applied for the execution of UML-RT models. UML-RT is a UML profile for development of real-time embedded system. In UML-RT, a system is defined as a set of capsules communicating through the ports. The ports are typed with protocols, and each protocol contains some input and output messages. The behavior of each capsule is defined using a hierarchical state machine that utilizes several notation, mainly basic states, composite states, transitions, pseudo-states, and actions expressed using an action language. An action can be assigned to states and transitions, and it can be executed when a state is entered or exited, or a transition is taken. The first step in our approach is the static analysis, which analyze the model and find elements that cause problems for the execution. We can classify these problematic elements in two groups based on the problems they cause: lack of progress and lack of reachability. Lack of progress prevents the model execution to be continued. And lack of reachability prevents the execution to reach relevant states that are required during the testing and debugging of partial models. To make it clear, here is a simple example in the context of the UMLRT state machine. We can execute this state machine, but its execution cannot progress after reaching state S1, and there is no way for the execution to reach state S2. The former issue is considered as a lack of progress, and the latter is considered as a lack of reachability. The next step is the refinement, which fixes the problematic elements in a way that the behavior of defined elements to be preserved and allows the user to provide inputs when the execution is stuck at runtime. Let's review a simple example of the refinement. Here, the state machine on the left cannot be executed since it does not have an initial state. To fix that, first, we add an initial state. Then we need to add a transition from the initial state, for which we have two options. Thus, we add a choice point and then add transition from the choice point to state C1 and state S1. This allows the user to select the suitable and desired next state during the execution. Finally, we execute the refined model with the help of a debugging probe. The model is executed, and when it reaches a problematic element, the control is passed to the debugging probe that allows users to provide input either interactively or using a script. We have developed a prototype called PMExec, which supports the execution of partial models. PMExec allows users to execute any UMLRT models as soon as the architectural part of the model are defined. Evaluation of our approach is threefold. We have conducted an online survey. Participants are asked to answer questions about the relevance of the execution of partial models and the suitability of our approach. The majority of the participants states that the execution of partial model is necessary, and our approach is a promising first step toward supporting the execution of partial models. Also, we evaluate the performance and overhead of our approach based on several use cases. The results show that static analysis, refinement, and application of user inputs can be carried out with a reasonable performance. Also, the overhead of our approach, which is mostly due to the refinement and the increase in the model complexity it causes, is manageable. Finally, we have formally shown that the applied refinement preserves the execution semantic of the models and the behavior of the refined elements. Link to the online repository of our prototype and a demonstration video are shown in this slide. Please view them if you are interested. Thank you.
All right, so welcome back. I am backstage with two of the authors, Mojtaba and Juergen. So if you do have questions about this last paper, do please put them in the chat. So a very nice work, Mojtaba, congratulations. I have a couple of questions. I'm curious about the user experience when executing these models, right? And in particular, if it's a larger model, right? So, have you found any practical limits to how large a model is realistic for executing in this manner as the user is prompted for what to do next?
So, I mean, in terms of user experience, we have not done any user experience study.
Yeah, not expecting
that was
that.
not easy to do that. But on the other side, in terms of how a model can be large, so the scenario that most of the time that I'm imagining for the execution of partial model is when the user tries to only execute or focus on a certain components. So even if the model is big during the development process, they often focus on a certain component. So I imagine we don't expect to see that, I mean, all the model complexity to bring up to the when the user trying to only debug a certain component. So in terms of the model complexity, so there's always a limited amount of options that user can go. I don't expect to see many options. On the other hand, there are also scenarios that user can write a script. So if there are many options, the user can write some customized script for a certain conditions, even they can use if or other type of programming construct to have a more customized input when there are many options to select.
Yeah. So, and I can imagine if they're continuing to do this a little bit and they write a script for the answers that they know already, right? They've done this in the past.
Yes.
And how are guards handled, right? So I guess it's triggered by an event, an input event. The machine isn't set up to accept it, and so you've got the trigger, you've got the source state, but how do you deal with the guard in that situation?
So if the guard is missing, we don't see it as a partiality. But user can specify some guards during the execution. So basically, I mean, we don't have a certain treatment for the guards unless when we have a guard that, let's say, when we have a non-determinism issue, so when there are more than two options, these are the places that we allow user to select. But other than that, when a guard is missing, we don't see it as a partiality. We just run it as is, or even when there is.
Okay, so let me refine that question a little bit, because that's not quite what I was asking. So if there's non-determinism and let's say there's more than one transition that could be taken, is the partial evaluation or the partial execution at that point considered just on that trigger? And can the user sort of insert a guard? Well, yes, we will. Actually, I do want that transition as long as this guard is true, or are guards not handled in this choice of a non-determinism?
So in general, for non-determinism, I mean, so there are in the case of non-determinism, we always take the first transition when the condition met. We don't look for the others with the execution of UMLRT. So we really don't have a special treatment for non-determinism, if I understand the question correctly.
So sorry. I guess I was trying to use your language. So the machine is stuck. The execution is stuck.
Yes.
Right. And you're trying to make progress. You've got an input, and you're asking the user to accept where the execution should resume based on this input. And I'm just curious whether the user is able to specify a guard condition on that. On
the interactive session. Okay. Not on the interactive session,
yeah.
But yeah, when they write a script, they can specify guards. They can exactly specify condition that the execution role can be enabled, but not when they do when they execute the model interactively. But with a script, yes.
So there is a question about this interactive aspect, right? So during the interactive aspect, you are effectively adding behaviors to the model, right? To the given model, right? As the user, says how the execution should proceed. And so, I guess the question is, are some of these, in the end spurious or no? Like the user is specifying that this is how the execution should continue.
I didn't get the question. Juergen, can you help me?
I think I understand. Einzug, thank you for the question. So the analogy here is, so the intuition is that the system would work similarly to a debugger. So when there's an instance of partiality, you can teleport the system into a different state, right? For debugging purposes. So this is not really what you want the system to behave or what you want the system to do. It's just for analysis purposes that you want to explore or teleport the system into, or have it examine a certain behavior. But then, as Mojtaba sort of alluded to, you can also then refine it, as you say, the model by kind of through a script, for instance, or through interactive session, increase the level of completion of the model by specifying what should be there, and that would then be persisted into the model. And then, yes, then it will be important that you that you add behavior that you really want the model to exhibit, and that you wouldn't put in anything spurious or nonsensical, right? So there's interactions with a model where you make the execution of the model sort of do something and go somewhere, and that's entirely just for the purposes of debugging. You change what if analysis, right? You change attribute values or something, again, teleport the state machine to different states. What if? So none of these things are things that you want the model really to do during execution, one thing. And then another thing would be to say, hey, this thing is incomplete, but now based on what I've done before, I know how to complete it. And now I'm using sort of this mechanism to specify what it really should be doing and make the model kind of less incomplete that way, right? And yes, then your question is very relevant. It would be important that what you then specify is what you really want the model to do.
So just to add to that, also we have an option for a user that they can save they can record their interactive work as a script, and then after they review the script, they can save the script into the model. So basically, there is a transformation between these three. So if user does a certain operation that at the end he thinks that that's the correct things to do, then a user can save it as a script and then save the script into the model, which will be the part of the model. Then the interactive input will be the part of the model at the end.
Okay. So that was those were two of my next questions. Was A, could it be saved to a script for the next time you execute? Yes. But you can actually go further and use it to in some sense incrementally refine the model.
Yes, exactly. Yes. Okay,
so we have 15 seconds left. I won't ask my question about the future work, but I am curious about the future work. I do want to thank you. It is very good work, excellent work. And you can join